Okay. Hello. Let me check out if the streaming audio is working. Hello. Let me check out if the streaming audio is working. Hello. Perfect. Can't find my own stream. Here it is. Gonna link it in the Discord and we can start. Hello. Okay, so hey everyone, welcome to the stream. We'll today implement finally the fun part of making an HTTP server. The coroutines and uring. So haven't done much since last stream. I've just updated the stuff to dos that we have done. So I'm gonna briefly explain what uring does and kind of how we're gonna interact with it to have async IO. So the main problem of our server right now is that in the case that we are stuck on one connection, we can't do much in the meantime. So if we go to server listen or listen, there you go. Here, as soon as the server start, we start accepting requests. But this is blocking. This just keeps on blocking until we finally get a request. And when we get a request, then it runs the rest of this. So wouldn't it be nice to do other things in the meantime, especially when reading and writing, which are things that don't require CPU time and can just be done with DMA and can be done asynchronously, and we can check the result right after the finish. Same goes with writing and technically with closing as well, but closing is kind of asynchronous already because it just returns immediately after you make the syscall, and the kernel is like, yeah, I'm gonna close it eventually at some point. So most importantly, it's to make the other parts here asynchronous, as well as file reading and whatever not in the future. So this is what uring helps with. Basically, you can imagine it as two squares like this that contain a ring of tasks. And you have number one, the submission task, the submission queue, and the completion queue. So you submit onto here whatever you want. So if you want to read, then you submit a read. So I'm writing with my mouse. You can submit many tasks at the same time. So you can just make one syscall and make a lot of requests to the kernel in one go. And then you can keep polling on the completion queue until it's done, and it just gives you the return value of that read. And that's why we will need an event loop, and ideally also coroutines. Do you have Parkinson's? Yeah. Okay. So let's get started. For the coroutines, we're going to be using Libaco, which is pretty simple. Basically, it has its own stack for each of the coroutines, and when you're switching between them, you can keep that state, kind of how like JavaScript does it, where if you do an await here, read, or whatever it would be, then here we kind of return or yield. And then in the event loop, we can continue doing other stuff and execute other tasks. Well, it's the same thing, but in C. And it basically just saves the registers that we have on the exact moment where we are yielding. So let's start with building. Hey, thanks for the follow, Wrecker. So to build, it's very simple. Just go to the releases, grab the source code, copy the link, and then just cd into vendor, wget tar xf and b1 whatever. Remove the tar file, and we're gonna rename Libaco to Libaco directly. Good. And instead of here, we have all these files. Actually, all we need is this tutorial, so we have some reference. The assembly file, which is the one that saves all the registers. The readme in Chinese, we don't need it. Images, no, and we're gonna leave the license. And this is what does all of the work, really. The main C file is pretty short, 500 lines, and there's a lot of if def, then do this, if def, then do that, so it's a lot more simpler. And the assembly file basically for x86 just saves all the registers and the current stack. Okay, so we're gonna import this. With echo and echo.h. Sorry if I'm shaky, it's just very cold. In here, there are a couple of defines that you have to set some options. The only one that we care about is async, because we're using async. So we're gonna define that. Oops. There. And now we have to add the library, or rather, we can just build the C file. So we can go vendor, lib echo and echo.c, and as well as echo sws, which is the assembly file. So now if we try to do something like the simple example they give here, where they just echo create, we're gonna remove that assert because we're gonna use our own assertions, and we build, not here. It builds normally. Okay, cool. So we're gonna do this event loop right inside of server listen, because you can expect that server listen just blocks afterwards. So you can't really do much after you server listen. So we're gonna create a function that is gonna be called handle client. And pretty much everything in here will go. I didn't delete it. Here, everything here. I'm gonna format it. Will go on there, and we won't have the while loop here because we will be doing the event loop outside of here. Oops, Control F. And as for the server, we're gonna keep it on a global state. So we're gonna grab server. There are better ways to do this. We're gonna just do it like this for now, and later we can maybe just pass it as argument. I don't know. It's just simpler this way for now. But usually you don't want to have global state. So server pointer, server, and then we state and init it. So there we go. That's what we have from our server. And then here, instead of continuing, we want to go to cleanup. Because we want to safely clean up. There we go. And cleanup is going to be this. All right. So this, well, and all the other discos we make are going to be asynchronous now. But first of all, we have to int some stuff in our server lesson. So, as we were seeing in the examples, they do thread init no, because we want to initialize our coroutines in the current thread. Then they create some coroutines and create the stack. So number one, they create the main coroutine, which we're gonna save on our state. So main coroutine. And then they share stack. So create the shared stack. So again, state. And we're gonna save this here, and I'm gonna name it shared stack. All right. And we're gonna save this right inside of there. And this is shared stack. As for stack, we're gonna create a decently big stack. So I'm gonna make it 64. It's just kilobytes or megabytes. I'm not sure. I believe by default it creates a 2 megabyte one. Let's see. So yeah, it's 2. So we want to multiply it by 64. Right. Okay, good. Next, we want to init our queue in IO uring, or we want to initialize the submission queue. First of all, I'm gonna set the server and state that server equal to server, which is a reference, but this will never go out of stack, so we'll be fine. All right, so for IO uring, I have this resource that is the creation of a web server in libIO uring. It's pretty messy, but I will just have it as reference. Because they do some stuff that is important. So we need to, first of all, initialize the queue, as I said. our queue depth is going to be 496, and we need to store this on state ring. And we don't have this because we didn't import live uring.h. And we don't have a state. I think it's IO ring. I don't know. Ring. It's IO uring ring. All right. Maybe I can just, there you go, struct IO uring or IO ring and ring. That's a pointer. There you go. And we can just do this. No. Yeah, it's definitely not a pointer. What is the problem? They pass ring and they define it as IO uring ring. Yeah. Field has incomplete type struct IO ring. IO uring. There we go. So once we init the queue, key server loops and creates the completion queue and adds the first accept request. So if you remember, because I'm gonna copy this, I'm gonna place it on our while true or right above it. If you remember, in our handle client, we removed, well, we didn't, but we're gonna remove the connection. And we're gonna create the connection from outside the server loop. So let's do that. Let's go server loop or server listen, and let's create the first accept. So they do this at accept request, which is a very simple function. All it really does is, well, he adds some extra stuff, but all we really care about is getting the submission queue, passing in the ring. As for server socket, we can grab it from our sock fd, and they pass in the client header, which we have again on our server. And what is this? Has to be a pointer, and we didn't copy something, I guess. What else does it accept? Flex. So as for flex, they pass in client header len 0, which is on server. And this has to be type sock len. So put it in there. There has to be a pointer and there has to be a reference. Like this. Client header len. And we're getting a problem. It's because there's no name, no member named client header. But we do have client header len. Without an underscore. All right. And then they set data. We're gonna set it to null, and we're going to pass in our ring. So basically what they do is they get the submission queue, which is the updated queue of submissions. We have to be pulling this all the time. Every time that we want to send another, what would it be? Another event, right? Then we prepare our accept event, you can call it. We set the data to it because we usually want to access some data inside of the resolution, and we submit it. And as you can see, we set it to null, but we can, set some state. So first of all, we know that if our data is null, we are inside of the accept. So we're gonna name context is equal to null. Then we do something else. We do another thing. How do we get the context, and how do we get the completion queue, or how do we keep on polling? So for this, he has his server loop where he waits on CQE. This is blocking, which means it's gonna keep on waiting and it's gonna sleep if there's no tasks. And then it's gonna wake up the thread and then it's gonna start. So it's pretty efficient. It pulls for some time, then it goes to sleep, then it wakes up. We have to pass in our ring and our CQE that we defined on here. And then from CQE, he grabs user data, which we don't need, but we do need to grab the context or the data. So number one, if this is, this gives us an error, it means that we failed to even get the request. So we're gonna just p error. It shouldn't happen, but it can happen. We're gonna just print whatever error we got on there. In the case it's all good, then we need to grab the data. There's a function that is uring get data, I believe, something like this. Get data or data. Right, you have user data. All right, well, we're getting no auto completion either. I do have some notes. It's CQE get data. All right, well, close enough. All right, and this returns a void pointer, which we can set to whatever struct we want. We pass in CQE, and in our case, we're gonna call this coro context. So it's gonna be a pointer to the context that we create. And here we're gonna store different stuff like file descriptors or return values from different functions and whatever not. Hello, Becky. So let's create this above. And it's gonna be, I'll just add int fd for the file descriptor, and we'll add more stuff over time. But for now, just that. In the case that it is no, we know that we are inside the accept because we passed no. So we're gonna check what is the response from the completion queue. For that, we can just do int response and CQE, and it has different things. We're just gonna grab response. So if response is higher or equal to 0, we're gonna create a coroutine. We're gonna so echo create number 1. This receives our main coroutine, which is basically this one we created, which tells echo where to come back. So it knows to come back over here as soon as we yield, which you're gonna see later. Then we need the shared stack, so shared stack. And we need a safe stack size, which we don't really need. And we're gonna pass in the function pointers and some arguments. So as for function pointers, we need to pass in a handle client, and the arguments can be our context. This is so we can read the context we have inside of the server loop, inside of the handle client function, because you're gonna see here echo function pointer does not take arguments. So the only way we get arguments is by using a function. So we create this and we're gonna actually store it instead of context. So we don't have this, so we're gonna name it coroutine. Coroutine, there you go. Oops. And we're actually gonna malloc and create this new context because we don't have context as of now. So coro context pointer, make this equal to this, and we're gonna get the size of coro context. And here we need to pass in new context. All right. Good. Next, we want to do is let me see my notes. We create. We set the file descriptor. I almost forgot about that because we need to know, to what we're responding to, and then as soon as this executes, this just gets inside of the handle client function immediately. And as soon as we access something like async read, and this yields, then it returns over here. So we can just echo resume. And this tells basically where we resume. All right, and here we can check if, for example, anything failed and the task is completed, which can happen. So for that, we can go to coroutine, and instead of here, we have this that lets us see if the coroutine was terminated. And if it's true, then we want to free the new context, and we want to also destroy the coroutine in this order, because if not, we're gonna be accessing a no pointer. And right as we do this, we want to queue up another accept task, because then we will not be accepting requests, right? So as we queued up this one at the start, I'm gonna queue up the second one. And yeah, now we have handled the entire case where we want to accept requests and we want to handle the cases where it fails. So then what happens if we get context, meaning we did execute some task in the handle client? Well, in that case, we want to kind of do the same thing as here. So we don't need new context because we already have context. We don't need, well, we do need the file descriptor, but rather we need a response, because it means that if we got here, we are receiving the response to something else. We don't need to create a coroutine because we already have one. And we can continue on with our task. And once again, we can check our coroutine. If it's done, then we destroy. Yeah, I believe this is it. So it's pretty simple. Or rather, our event loop is extremely simple. We can later add, are you using Libaco on top of uring to omit callback hell? Yeah, because if not, you would have to use something like uContext or callback hell. Because there's no way or no sugar syntax in C to yield or await. All right, so finally, inside of here, we need to grab the new context. So let's grab coroutine context, and we are gonna echo get args. This automatically knows in which coroutine we are, and it's gonna return us the data that we passed in echo create, as you can see in here, in context. All right. And we know that in context, we do have our FD. Now we need to make this async. So we're going to create our own little function that is going to handle the async read. And we're actually going to use recv because it's better. And this should respond with size t. So how do we create the equivalent read function but asynchronous? So it's actually very similar to the accept. In fact, it's pretty much the same as the accept in here. We're gonna grab the submission queue. This has to be below state. We're gonna grab the state server sock fd, and actually we're not gonna pass in this. We are gonna receive core context pointer. We're gonna pass the file descriptor we get here, and then I'm gonna grab the server, grab the client address, and same goes for this. And this is failing. Oh, it's because it's state. Dot. All right, there we go. So get the SQE, replace this with prepare recv, and of course this has different arguments. We not only pass the file descriptor, but we also need to pass in a buffer and len. So let's do that. Our buffer, it's gonna be void pointer and whatever we pass in here, and the size of our buffer is going to be buff size. And we can just pass in that directly. There you go. And the last argument is flex. We're not going to pass any flex. So that's it. And we can return whatever the completion queue responded with. So the way we do that is, number one, we need to echo yield to return to the what's the name, to the main function. So when we echo yield, we go back to resume here, and as return, we're gonna return whatever we got in a response. Also make sure to pass in the context as an argument in setData. All right, and since we're kind of doing the same thing each time we create another async function, we're going to create something, well, a simple extraction, which is going to return an int, and it's just going to be echo await, or rather co-await. And it's going to receive similar parameters. Actually, all we really need is the context and the SQE. And we can just return everything in here and just call return co-await and pass in the context and the SQE. So now in our recv function, we can just async recv. We can just pass the context directly, and we don't need to pass flex. And Salem will go for our read function here. We can just rec b, pass in the context directly, and whatever we're missing, buffer size, sorry, async recv, there you go. Pass in the context, request buffer, and buffer size. So we already have recv managed. We have this one managed. We need to make our write, or our async write. Hello, SHH. So to do that, we are just gonna recreate our async function, but send. Send is about the same as write, but it's again better for servers. Is it neovim? Yes, it's neovim. And here we just add send, and actually everything else stays the same. So go back to our write, async send. This is the context, and everything else stays the same. And our other write, again, that's in the context, and there we go. So yeah, now we've replaced all the normal functions with async functions, and the last thing we need to do is in our cleanup, we need to close context fd. And as I said, close is almost asynchronous. It's just a simple syscall, and the kernel kind of decides when to close it and when to not. So we're just going to leave it like this because it's faster if we just make the syscall directly. And the other thing we need to do is we need to exit our coroutine. So it basically, the coroutine manager knows that we are done. So when we make the comparison, it's going to enter in here because we finished. And as you can see, it's going to enter here if our accept fails. Or, well, not only if our accept fails, but if our read fails. Oops, where's this? If our send fails, if our read fails, it just goes to cleanup, closes the socket and exits. So yeah, I think that's it. We're gonna build. I get some errors with the build, and I get a error that your uring submit can't be found. It's because in here we need to add IO, or rather just uring, and actually I'm gonna add it on here. Uring. Yeah. And that should fix the problem. All right. And now we're gonna make a simple request to check if it worked. And we got an abort when we try to resume on here. So let's go to 4 or 5. Try to resume the coroutine. And I believe it's because we need to resume on our main coroutine. I think that's why. So another HTTP call, and it aborted on main. It doesn't really tell us why. That's weird. Yeah, it fails. It says line 4 aborted build main. Oh, right. That's our build. That's not even... line 4 is this. I believe it's because I'm doing this, I guess. Yeah, most probable. No, it says 6631 core dumped. So it does not accept the request even. I'm gonna check my notes just in case I forgot something. No, it actually was the new coroutine. We are passing the shared stack, we're passing the new context. That seems fine. Our init, we init the thread, we pass in server, we create the coroutine, we create the stack. Maybe this is too big. I'm just gonna set it to the normal stack size. And we create our queue. Normally, okay, good. Then for getting data, we get data and we forget to mark it as seen. It's my bad. Basically, marking it as seen means that we read it and we tell the completion queue that, hey, I did wait to get the task and I did see it. So next time that we try to see it, it's not going to be there anymore because it's removed. And as for submitting and anything else, we're doing it correctly. There we go, good. So we're gonna look for our users and it responds with users. And if we try to submit a new user, so username, test, and email, test@gmail.com, and then we try to get it back. It does respond with the user, and we're done. Thanks for the follow, Darren. What mic do you use? I use a Elgato mic, the basic one, the one that everyone uses. This one. Yeah, looks like it. Is it good or bad? I think it sounds generic. Sounds good? Okay, good. And there we go. We finished our async server, or at least the synchronous part on here. So we can mark this all as done. We have our event loop. We are handling the socket. We are, oh wait, not add this. And we are reading, and oh, we're not doing this either. Okay, so we finished the basic part. Oh, I didn't know that you were responding to the other guy. My bad. All right, now we are gonna do some basic cleanup, and no, well, first we're gonna go through how everything works, just for anyone that got lost in the way. So number one, we create our server. There's a standard server creation. We create the socket with sockstream, which is a TCP server. Then we set the reuse adder and reuse port. So if we were to build and delete and build, it can use the same socket fast. We set some stuff over here. Then we bind the socket, and finally we listen so we can accept connections. And that's what a new server does. Then we add some paths, which is just a basic server path. Add this, and yeah, you just send the function pointer. The way you accept functions as parameters in C is actually very simple. You can just create this type. So it's a pointer, and this is the return value, and these are the arguments. That's it. The server post doesn't look much different. It just adds a method post, which is from our enum here. And our listen sets the server as global state. I think I'm gonna clean that up. I don't like it. Then it inits the coroutine. It creates our main coroutine. It creates the stack. And we init a queue of what's the name of submissions and completions. Then we create our new our first accept. So as soon as this starts, we can start accepting requests. We define our completion queue variable, and on a while loop, we just keep on getting completion queue tasks. As soon as we get one, we get the data, we get the response, and we mark it as seen. So uring knows that we finished it. In the case that it's no, we did set the data as no by default. So we enter in here, and we know that we are on an accept, and we're at the start of the request. So we create our context, we create our coroutine, we pass in our main coroutine so it knows where to come back, we pass in the shared stack, we set 0 for safe stack, pass in our function, and pass in the new context. We resume on here, so we know where to resume at when yielding. If this is done, we can return and destroy everything. And in the case that this isn't higher than 0, meaning that the accept failed, then we can create another accept and queue it. So we basically do the same as in here, just queue another one. Hello, Mr. Bart. Yeah. So that's for the case of accept. And if we did get context, it means that we are on a write or a read or whatever not. So we can resume on it, on the coroutine. And in the case that it ended, then we just free. Else we repeat the while loop and we do the next thing. So the flow is, it gets on here, it creates the coroutine. As soon as it creates it, it starts it. Then we go into handle client. We execute all of this. At some point, we get on an asynchronous function, in this case Requi. We return at some point with await. This executes on the background and on handle client. As soon as we, sorry, not on handle client, but server listen. As soon as we yield or we await, we come back to here and we check if it's done. Else we keep executing and keep on going on that while loop. And that's it. It's very powerful. It's almost like we're writing JavaScript on C. And I find it very cool because now if we would get hundreds requests per second, and one of the clients would be extremely slow in sending data or whatever not, our server won't be extremely slow. It will be the same speed because we will be handling everything asynchronously. So, now we're gonna add basic file reading and file writing, I guess. And we're maybe gonna clean up some of the stuff here. So I was planning for a different API. I think this should have a status in here. It's gonna be size T. And we can just set the response status equal to status. So instead of having to do this, you can just do 200 here, and that's it. And same goes for, no, we don't use JSON anywhere else, good. And actually, writing here, it'd be cool to return 400 and just return a string, really. That, No, I think this is fine. Yeah, just return an empty string if you fucked up. And I could just say invalid JSON. Give no context about it. And here we should probably free our the JSON. Okay, see JSON destroy or delete. I think it's destroy. I'm just getting no autocompletion. No. See JSON. I'm gonna look at the docs real quick. So free. Nice. Delete. There we go. And in here, I believe we also have to delete. So right at the end. And in this case, we need to delete email, username, and users JSON. Username and email. Yeah. Now, this only happens if we get here. So I believe we should have a cleanup. And we can set as response just some basic string response, and it's equal to nothing at the beginning. And we just do response equal to this, go to cleanup. Same goes for this. Oh, I forgot to. Response is equal to this, go to cleanup, and here as well. All right. So that properly cleans up everything, I believe. Let me test it, because variable was set but not used. It is, though. Yeah. Oh, it's because we're not returning it at the end then. Yeah. There we go. Response. I think that I have warnings. And it fails directly because we're trying to free memory. We're trying to free, but we're using it here. Okay, you know what? It's fine. We can just not free it, you know? And yeah, same case would go for this. It's almost like this should be asynchronous too, or like save the response on the response header here. We're gonna see how we handle that later. So I would like to create this file reading and file writing. So let's do that. So it should look very much similar. And I don't know if there's any purpose on looking around here. Yeah, that's fine. So let's go back to async here. And I'm not sure what we were gonna return here. So async, I'm gonna call it read file. I'm not sure what we're gonna take. I'm not sure what we're gonna return. So this is gonna be interesting. So we definitely have to pass in something to read upon. So first of all, how to read file in C, not C#. Okay. I think I'm gonna look at the Reddit response because the other ones don't look very good. So they do fopen read, and then they store it on here, right? Open read printf close. Fopen, open, and save it on here. So I believe there should be something like fopen. There's not. There's only open. Oh, there's no open either. Well, it's not good. Open. Rename. Make dir. Fopen IO uring. I don't know, we have to find this out ourselves, I guess. So if you're using the uring, you just do register files. Open, write, close. Open, write, and close. Okay, so they register the file. Then they open it direct. What is this naming? And finally, they prepare the write. And then they just write to it. IO link, IO fixed file. All right. This is really ugly. Damn. So set the direct descriptor table to a single directly unused entry. So this is empty. Then they register the file. And this should give us file struct. Then they do this again. Direct to. And you give it the file name. As well as. Okay, wait, let's see. So number one, let's do this directly. So get the SQE, open how, we open create or O read only. And mode is 0666, which is must be 0 values unless one of are set. Okay. And then that's in state of the ring and the file name. So in our core context, since we're not inside of our server loop anymore, we cannot get it like this. We should get it like this. Instead of the function itself to make it easier for the user to read the file. So get SQE, direct open. We need to pass in our file name. And we need to pass in dir fd. What is dir fd? Okay. just a parameter. And next, what they do is perform write to same descriptor, which we're not going to do, but we're gonna need a write function. So let's create it. So write to file. And it should take in a buffer, the count, and that's it. I guess the file descriptor too. Yeah. Yeah, most likely. And then they do IOSKey IO link. All right. Oh, there's actually documentation here. I would like this to be darker. Okay. Maybe there's a read file, or yeah, just read. Prep read. No, there's no examples. Okay, actually, I think I'm gonna look at the example. All right, so they get the file size directly, just fstat. So we're gonna make that synchronous, I guess. Or we could make it asynchronous too. So get file size fd, yeah, ioctl. It's not imported, so let's import both stat and that. So right under here, good. Peer that, yeah, return -1. Then on our read, submit read request, they open, get the file size, bytes remaining, offset, current block, file size, blah, 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 malloc. And then for each block of the file we need to read, we need to allocate IO back struct. So they allocate all of it, and then they prepare the read and set the data. I wonder why not do everything asynchronous? So async, actually I'm gonna keep that as an example rather. And it's just gonna be async read file. And I went to do this, and I meant to comment this out. The write is simpler, just didn't know how to do the read. So then they pass in block size. Which I'm guessing comes from, okay. I wonder what is that? What is blocks? Oh. Right, so they have some sort of vector IO back. Okay. I'm gonna define it on here. We're probably gonna abstract this too. I don't really like this code. So they get the file size, the remaining bytes, the offset, the current block, get the amount of blocks, then the malloc, the buffer, and the file info. And for each block of the file we need to read, we allocate IOBEX struct with the index into the IOBEX array. This array is passed in as a part of the submission. If you don't understand this, then you need to look up how readv and writev system calls work. Okay. I'll look it up later. +6 mem line, all that, get an SQE, set up a readb operation. Right, I'm unsure how readv works. I think it's a vector, like this is vectorized. And then this is the user data and finally submit. Right, and like before, right as we submit, we should return co-await. And we need to get the context. So we're gonna get it from here. Right at the start. I'm gonna format this properly. Right. Unable to allocate memory. This is bad. I mean, if malloc fails, you have bigger problems, right? Yeah, this is fine. All right. So that's it. Let's check if this works. So let's add this. No, never mind, not here, but get users. Let's just async read file, give it a file path, so build.sh, why not? And we need to pass in ring. Which we have in state, and same in here. So I think it needs to be yeah. I mean, we're doing this on other places, right? Yeah. Right. And this should return file read, or whatever they named it, submit read request. Yeah, and at some point we check the response of it. Then they get the completion queue. This is the callback hell of not using coroutines. They wait for the completion queue, then they get the data. And depending on some cases, it may be, in our case, sockets, or in other cases, it could be file info. So when we set the data, we set here file info, hence why this happens. So I'm unsure. We have the context in here. I guess we could have in our context something that tells us, hey, you're reading a file, and hey, you're doing, you know, some socket stuff. So let's do that. If we have no context, then we know that we're doing an accept. If we do, though, we're gonna check context, and instead of there, or we could pass in a context. No, I think it's fine. It's fine like this, because we're gonna have to create it anyways. You know what? I think the right way to do it is setting the context. So, new context. There we go. And instead of context, we're gonna have the operation type. So I'm gonna name it op type, and it's gonna be type, and this is just gonna be enum, which is gonna have op type. And inside of here, we're gonna have accept. We're gonna have read file, and we're gonna have other, I guess. So we fall into other, which we're gonna know that it's just read and write stuff from our sockets. And we know that read file is gonna be just for whenever we're reading. So I guess it could be other socket or socket handling, I guess. So we know it's just standard socket handling. All right. So in case the op type is that, then we're gonna grab what I believe was file info. So for context and file info. And this could become an union at some point. Like you can contain int fd, or you could contain fi. If you wanted to optimize it, I'm gonna keep it simple. All right, so I'm gonna remove this. Already got it. And right on here, as we are setting the context, number one, I'm gonna context fi equals fi, and I'm gonna set the type to write file or file write. I'm not sure what we named it. Okay, context op type read file. My bad. There we go. I'm gonna do it right before. So we submit context. And we don't need either of this because we are already doing set data, or rather we do need set data. Yeah, but we don't need the submit. There you go. All right. That's good. It's actually, there's no point to do that here when we could do it here. It changes nothing for us, and it's cleaner. So same would go with the submit that we have here. We don't need to, where is it? Read file, set data. Okay, that's good. And in our server listen, in here, if context is null, this is not going to be true anymore because context is always going to be true. So rather, if context type is equal, and then whatever, in our case, it will be accept in here. So we have to set the new context type to be equal to accept. In the case that it is an accept, we do whatever, and then here at the end we have to set it back again. Oh, we're doing state machine in the main lib now? Yeah, I mean, it kind of comes to that at some point. Especially if you want timeouts and whatever not. So we no longer need this. At the end, if we finish this, we free it, and else we want to queue up another task. And I feel like it should be here. There you go. And yeah, I'm gonna add it on top here as well. Make it cleaner. All right, and this is the case where it's an accept. In the case that it is I like to do this, continue, and then just make another if. So in the case it is, what do we name it? Socket handling. Then we do context type equal to socket handling, and then we do all of this. And in the other case where it is well, actually, now that I think about it, since we pass file info through the context, we don't really need to do much else, right? And here we have our co-await, but we actually can't use it on here, but we can just return or fi. Yeah. File info struct pointer. Yeah. And file fd here could just be an assertion. So if it is lower than 0, then we do whatever else. I guess I'm just gonna say open failed with error and file d. There we go. And so I would go with this, I guess. This makes it so much easier. Yeah, POSIX memo line failed. FD. Which shouldn't fail, I mean, and if it does, you're doing something wrong. I guess it's debatable if we should assert or if we should return an error. Since this is not production, I'm just gonna keep it like this. And in the case it's all good, then we just return fi. So the type I was doing, this, is not necessary actually. It's not necessary now, but I feel like at some point we might need it. Wait, actually we do, right? Because we need to update this. Or do we? Yeah, we do. We do. Okay. Yeah, we need to grab context fi, and we need to update it from the event server listen. Yeah. Listen server. Okay. I always forget the name of this function. So if it is socket handling, we do that, and if it is file or read file, then we set the context response to response, which is an int, and they also do where's fi? I think get data. Yeah, this. Get data, and in our case, it's always going to be context. But we have to update the fi, well, res with res and fi with context fi. No, it's updated. Then I don't know what I'm doing, honestly. I think this should be fine directly. This returns struct file info pointer info, and I think we can just log info directly, info, and whatever we have on here. So it's iobex. I don't think we should be using iobex. What does each iobex contain? Base and len. Structure for scatter, gather, IO. Right, and the way he prints it is by output to console and this, which is not cool. Name it fi, and output to console. In his case, it's just fputc that. Unused variable, okay. Buff. So at some point we malloc buff, but we never use it. Char pointer buff. Yeah, and the same buff is never used. Nice example. This channel is legendary. Thank you, Elias. I'm not sure what he sets the buff for, because this is for the file size. But he never uses it. Okay, we're just gonna comment it out for now. So something weird happened there. It accepted 2 connections. Yeah, connection accepted and connection accepted. And I think it's because we're queuing twice, perhaps. Oh, I know why it is. It's because we are not setting the context type. So in the case that it is socket handling here, we're not setting it. So let's go to async here and context type. and I guess it's socket handling. So for recb and send, and then for the rest it's normal. And then for here we set context fi and type, which we don't need because we're returning here fi anyways, but you know. Okay, at least it failed, that's good. So we fail on file fd is less than 0. And I think it's because with error 6. How do you handle strings in this project since they are a pain? See, what did you use here? I used a combination of functions that I had defined in my standard library and functions that I created over time. So, for example, I have this one, this read until, that basically goes around the buffer. So if I want to, for example, read this, I send in the buffer, then I send in the place where I want to store it. So in this case, it's buffer, the size of it, and where I want to stop. So I want to stop in the first space. And same would go if I wanted to read from here to here, I would just stop on R. You still use null-terminated arrays of chars? It depends. If I'm interacting with the standard library a lot, which happens in socket programming, yes. But else I use my own string type, which it's this one. Just length with data that does contain a null terminator. The only way you would not do that is by having abstractions over every single function of the standard library, or you could do it like Go and basically write your own standard library functions with syscalls. I wouldn't recommend that. It's a pain in the ass to maintain, but it's possible if you don't want to handle strings from C. Also slices, yeah, pretty much. There's no happy path in C. Okay, so we're getting 6. It's because this has to be higher, I believe. Okay, and this fails as well, because I did the assertion the other way around, or what? This returns 1, so failed with error 6, and I printed file fd. Nice. I should probably save the error so it's more debuggable. So mem align result, and we can make this an int, this mem align result, and here we just print it. Should have used Zig. You're shaking my head. Yeah, I mean, it's C is painful because it just gives you no built-in tools. That's the reality. The standard library is pretty bad You have to make your own abstractions over everything. But once you have your abstraction layer set up and you've done everything how you wanted, you kind of have your own language. You have your own standard library as well, which is cool in its own way. And in Zig, you have to stick with whatever the creators chose. So I'm getting this warning here. Non-entity declaration of handle client. So because we need to return void in here, and then in line 514, we're getting error dereferencing freed memory context. And that is because we need to continue here. It's only missing generics in my opinion. Not really. I mean, if you use GNU extensions, not really, because you have the type. I think it's an operator. Let me see. Where do I use it? I don't believe I ever use it here, really, because it's not that necessary even for implementing vectors and hash maps. But in my main library, my build system, I do use it a bit, or not at all either. It's a type of? It's type of. That's it. It basically gives you the size of something, and then you can use it however you want. There's type of, which is the GNU extension, and then there's type of or type that I think comes from C11 or C23. Namespaces would be cool. That's pretty much the only thing that I would like. But it's not quite the same. Yeah, it just gives you the size. Agreed, but generics without fucked up macros would be nice too. Yeah. Yeah, I mean, I can't disagree with you. There are a lot of features I would like in C, but then also C works without them, so the only thing I would really like is modules for faster compilations, and because it's easier to have stuff around and you don't have to, add weird naming to not collide with standard library functions or whatever not. But module system would be really cool to speed up compilation, because you can just make it parallel, right? Because nothing interacts with each other and each file is its own thing. Or each module, rather. C does have faster compilation if you look at C++ or Rust. Yeah, I mean, as far as you use meta build system and you divide each file that you're compiling into different .o files, .object files, then yeah, sure. If you're compiling a lot of files and then creating an executable, but you're not doing them parallelly with something like Ninja or Make, then it gets slower over time, right? It's still pretty fast even if you're compiling 50 files. How's that different than size of? The thing is, with type of, you can compare types. Where's my... Or I can just give you an example. Let's see what the AI says. So you can use it like this, number one, which is extremely cool, especially in macros. You can just grab the size. It's like using auto in C++ in a way. And you can also use it in here if you want to, I forgot what's the name, to typecast. And then you can just use it as way to check size as well. Or, to do stuff like this. It's basically for assuming the size, and the compiler helps you. Okay, I'm unsure why my file failed with error 0. Okay, failed with error 0, so does not equal, or rather has to equal 0. And I'm not sure how this fails. Open C. What are the return types of this? Sorry for the flashbang. Upon successful compilation, the function shall open the file and return a non-negative integer. So it has to be higher or equal than 0. Right? Yeah, there we go. And yeah, look, we read the file. And I believe that was asynchronous. But let's check. So let's say here we yield, so log info, reading file async, ... And then in, what would this be? In here, finished reading. Yeah, and then we yield, or rather we resume the coroutine. Yeah, so reading file async, finish reading, and here it is. Well, YouTube really does not want me to show the stream live to me, gives me back about 30 seconds. Yeah, that's the bad thing about YouTube. In general, it just stays very behind, even if you're moving forward. Just move to Twitch. Anyone that is on YouTube also, move to Twitch. It's much better. All right, so there's one thing that I don't understand. So we have file reading. We need file writing as well. So let's add that real quick. File read file. Yeah. But I believe it should be much simpler than whatever that is. It's something like this, I guess. Except we have to give it our own flex. Write file. So again, context, we don't want to grab it because we want this to be clean to use. Then we do pass void buffer, which most likely will be a char buffer, and the buff size. We could pass a string as well. And then it prepares the send. So I would like to see it is how do they write? So they implement a copy command, which I'm guessing it's gonna write. This is the qread, and this is the qwrite. So you just need IO data, and you set data equals 0, the offset to the first offset, IO base, data plus 1, IO len to first len, Q prepped, and submit. Q prepped. If data read, then this. If write, this. And they still use this vectorized version. And they said understand. If you don't understand, then you need to look up how readv and writev system calls work. So readv. Let's look at it real quick. They pass in an IO back and then IO vector count. Readv system calls reads IO b count buffers from the file associated with the file descriptor fd into the buffers described by IOB scatter input. For something like dynamic arrays, would you prefer macro-generated type-safe solutions or the fat pointer approach, where you put data into the dynamic array before the first element? It kind of depends on how much type safety you want, I guess. You could auto-generate all of the different functions for the vector, which is doable. Someone in my Discord did it, actually. It looked pretty interesting. Well, I don't know. I'm not gonna find it. But yeah, it was basically the vector type definition that I do in mine. So vec type, basically this. And as type name, it would just concatenate everything on there. So backpush and whatever would be defined in here. The thing is, it would create big object files because you're gonna have a lot of functions, right? That's the main downside. But then I would say it's up to you. It's up to how much developer experience you want. And I think for what it adds, it's not that good anyways. But up to you, of course. Write EV. IOV count buffers that are described into the blah, blah, blah. So I get all of that. I would just really like to know what IOV is. IOBEC. Vector IO data structure. This is the starting address. This is the size. And describe a region of memory beginning at IOV base address and with the size of that. System calls use arrays of this structure where each of the elements of the array represents a memory region and the whole array represents a vector of memory regions. The maximum number of IOBEC structures in that array is limited to IOV max. It's just a very ugly structure. not a fan of it, really. And then you have the pre-versions. Okay, well, in the case that we want to write, in this case, write v, we can't pass in buffer, or rather we can, but we have to transform it. Now, do I want to do that? Not really. Honestly, I would prefer to just write directly. And as for how do we get the file descriptor, I guess I'm gonna do it the same way as in here. So we just open it and that's it. Of course, we need the file path. Or file path. So we need file fd, and we need to respond with the response directly. I think I'm gonna add accept, read file, and generic. Because in the case that it is generic, then we don't need to go around that much. Yeah. In the case that it is generic, meaning it returns a response normally, then we don't have to do much. So generic. I guess it would be cool to handle that first, assuming the best case scenario. And whatever that is. But then it's like we don't even need read file. We can just use generic. I'm gonna keep this this types though, just because at some point we're gonna have timers and whatever not, so yeah. It's the same, right? We just returned res as the context in the case that we needed it. Echo resume, and yeah, that's it. Okay. So I'm gonna build it. Does build fine. All right, so let's try and use it. Let's go to get users, and we do this async read file onto build.sh. Let's actually create a test file.md, I guess. And we're gonna just async write file, give it the path. So in this case, it's gonna be test file md. As for what we want to write, let's pass in a string actually. So this is a test. Then we pass in the string directly because it's just cleaner. Buff.data and buff.length. Yeah, and we don't need to add the no char, so I'm just gonna keep it like that. Yeah, and then when we read it, we want to read that same file that we just wrote to. So there's gonna be this write, then it's gonna be asynchronous. We're gonna look at other tasks. We're gonna write. We're gonna read it, and then it's gonna do the same thing. So our I/O should be extremely efficient. And it did not fail. But I think our write did not work. We get the file descriptor. Then we just write onto filefd with buff data and length. I guess you can't do that directly. Write file with IO uring. So this is Go, but it's fine. I have mangpack copy. What? Allocator. Okay, so read and bytes, and how about a write? Okay, well, the read itself, how is it? So open file, then at the end close it. We're not closing the file, by the way, now that I realize. And they just use file read. So that's not what we want. Are you uring basics? I feel like this is gonna be the same thing. Yeah. Descriptor-less files for IU uring. That is kind of what we want. So this is what we saw before. They were registering. That would require us to rewrite, and then they have prep write. IO write request, the submission queue, SQE. Well, that's what we were using. But they don't have any examples, unluckily. And as for the example in here, where this is cat now, yeah, we need copy. They get the size, Q prepend. If it is a read, then they do this. If it is a write, then they use EV, or V, sorry. And then they pass out FD. That is interesting. Oh, I think I know what is going on. Yeah, we're passing O read only, and we want O write only. That was it. I think that's it. Yeah, nice. So reading file async and writing works. There we go. Now let's keep it simpler. So instead of read V, we're gonna read directly, and right, the main problem is that we need well, no, it's not really a problem, right? We have bytes remaining. We just need that, I guess. We malloc file size and yeah, that's it really. I mean, what is that file info? File size? fi. Ah, right. And what is this fi? Where do we get it back? Okay, I think that's just the case for what this returns, but I think we should get a string back, or rather we're gonna just return our string, so we don't need it. So this we can remove, this we can remove, this we can remove. And with this, fi, we no longer need it. Then here we just need the buff and file size. I'm not sure if we need +1. But yeah, here we just return buffer and char. We should probably return a, oh look. Yeah, let's make this better. So type def struct file info, and it should have the file size. And it should have the char whatever data. And yeah, actually, I think we don't even need this. We can just return a string. Keep it even simpler than that. I'm gonna add a to-do close and free. Some easy way, like something like free file or... Yeah, I'm not sure. Anyways, so I guess in here we just do string. And this could be string new. I forgot what the arguments are to my stir new, maybe. Yeah. And you have to pass in an arena and char. But we know the size. So in this case, the arena will be the same as the size. So arena, new arena. I don't like this anymore. Okay. I regret. I regret. Instead of returning that, we return file info. And then we create a function that is something like free read file. So file info, and then we just created data is equal to the buffer we create and file size is this. And just rewrite this to file size. All right, let's see. Now this will fail, of course. So file info, that, and we can just print it actually. File info is equal to file info dot data. And async write, yeah, we're just gonna add a new line here so it looks better. So if I build and I try again, I get an error because we get a buffer overflow, and I think it's because we don't write the null character. And this happens on log info. Yeah, I think it has no character at the end, that's why. So I'm just gonna buff bytes remaining is not used. File size, and it's equal to that. All right, let's try again. We can clean up a lot of stuff if we get this right, yeah. And look at that. That's correct. Now that new line that I added, I don't think it's good. All right, but there we go. All we really need is to clean up the API, cut the rough corners, but that's it. Like a lot of this is already done. The very core is done. I'm just gonna remove everything that I added from the back type. Yeah, block size, here it is. Nice job, thank you. Thanks, Darren. So I'm gonna be cleaning up some parts of the server. Tomorrow I'm gonna do another stream, and it's probably gonna be the last stream. We're gonna add optional body parsing, add the context struct, properly free all resources, and at some point, maybe in future streams, maybe off stream, I'll find errors with fuzzing, stress test, and other stuff. But probably before this, I'll make the new video showcasing the server. Anyways, thanks for everyone that tuned in. Join the Discord. I'm there all the time for anyone that wants to chat. And yeah, see you probably tomorrow. Goodbye. I feel like I would never be able to do this. Things like this, like, thanks for the stream while watching this. I realized how much I need to improve in the future. That it's very much possible. I didn't know C at the start of last year, and I got to this point. I don't think I'm an expert, but I got pretty decent at it. Anyways, thanks everyone for watching. See ya.